today we are going to talk about petrochemicals from natural gas. So the first I think I talked about last lecture about the building block and the petrochemical based petrochemical or the raw material of petrochemical industry. In general, petrochemical industry are based on three main raw materials or feedstock, which is the crude oil, natural gas, and coal. They are the main feedstock for the petrochemical industry. There is other feedstock or other sources for the petrochemical industry, which is non-conventional sources or is not of primary use. The primary use is mainly concentrated on natural gas, crude oil, and coal. So, in general, we can use natural gas and coal and crude oil to produce all these building blocks. From this building block, it is the starting point. This building block are the starting point for all the petrochemical industry or any end product or intermediate product for the petrochemical industry, as we can see in this figure. Okay, so here is the sources, which is the crude oil, natural gas, and coal, and these red circles are the building block that we are seeing here, and then the yellow dot are the other products that based on each one of these building block can be used to produce each one of these. So in general, the building block are sometimes they are paraffinic, they are olefinic, they are diolefin or aromatics. Okay, of course, aromatics cannot be extracted from natural gas. It can Natural gas can be converted like using new technology like the gas to liquid technology, which is a Fischer-Tropsch technology, to produce aromatic, to convert the natural gas to aromatic. But generally, natural gas contain paraffins. Okay, so this table contains the main composition of the natural gas, which is paraffinic based material. So it is mainly based on paraffin. No olefins in natural gas. Aromatic is very, if exists, it's a very small it is associated gas, but it is not. Generally, it is paraffin. So the natural gas is methane, as we take from the reservoir. Okay, not the natural gas that we have in our home or that is used as a fuel in the industry, because the natural gas that we use in our houses or homes or that is used as a fuel in any industry is mainly methane. But the natural gas that we get from the reservoir contain many other compounds, which is paraffins based, which is methane, okay, ethane, propan, butane, and pentane in heavier. There's other non-hydrocarbon components that we talked about how we cleaned this natural gas and separated each individual component to be able to use it in the petrochemical industry. So let's go back here for the building block. So as we can see from the building block, we have methane. So we can expect that the methane is one of the components of the natural gas. We have ethylene. Again, it can be. We will see. We'll talk about ethylene, how it is related to natural gas. And we have butane. Again, it is a paraffin which is existing in natural gas. Butylene can be converted using natural gas. Propylene also is an olefin, but based on a paraffin which is existing on in natural gas. Butadiene also is a diolefin. Also can be extracted from butane. The three other things, which is a benzene, xylene, toluene, which is aromatics, cannot be extracted generally in a direct way or using conventional ways from natural gas. Okay. So, what about the benzene, toluene, xylene, or other? Are there any sources that we can use to get this benzene, toluene, xylene? Yes, actually, we can use the crude oil. So, the crude oil industry, which is based on the refinery industry, we can use it to produce benzene, toluene, and xylene, and the other gases also. It's called refinery gases from the different process. Atmospheric distillation, we get some gases from the top, which is mainly propane and butane. From cracking, we get also gases, catalytic cracking. From thermal cracking, we get gases also, which is paraffins and olefins. So All of these components are the basis or a way to reach the building block, which is the starting point for any other petrochemical material, based material. So this is the distillation. So to sum things up, we have here crude oil. The crude oil, the main component in the crude oil that is of main importance in the petrochemical industry is the naphtha. Okay, is the naphtha. And the naphtha can be produced from the distillation tower, or can be produced from the thermal cracking, or also can be produced from the catalytic cracking of crude oil. So naphtha in general are the way or the source of benzene, toluene, and xylene, and for butadiene. So what about natural gas? We have natural gas here. Natural gas, we can get methane for as a building block for the petrochemical industry. We can get ethane, propane, and butane. All this can be converted to ethylene, propylene, butadiene, and so we can reach to the building block from the natural gas using the paraffinic-based materials. So this is called the primary building or the building block of the petrochemical industry. Is sometimes called the primary petrochemical, which is the green circles I talked about the last slide. As you can see here, all the table here shows hydrocarbon intermediate. So we have a hydrocarbon intermediate for what? For the petrochemical industry. So all these components are needed or in somehow used in the petrochemical industry and can be produced from all the building blocks. Okay, in general, yeah. So, um, so for the olefin, so we have for the primary petrochemical, we have olefin, which is ethylene, propylene, butadiene, butadiene diolefin. We have paraffins, which is the methane. We have aromatics, benzene, toluene, and xylene. So this building block can be used to produce other materials. So for example, ethylene here can be used to produce ethylene dichloride. And ethylene dichloride can be used to produce polyvinyl chloride. Okay, it's a vinyl chloride and then polyvinyl chloride. So based on the ethylene, we can end up with a polyvinyl chloride based material. The polyvinyl chloride is mainly used in waterproof substance or materials or plastics. It's used in the plumps as okay, the pipeline entering your house. Okay, also it has many uses actually. Okay, so well, this is an example. Also benzene, for example, can be used to produce styrene, and styrene can be used to produce polystyrene. Polystyrene is one of if you know your coffee, if you drink every morning a coffee, you go to Starbucks and you get a paper cup and a plastic top. Okay, where the two plastic cover of this paper cup. The plastic top you will find a code called 6. Okay, so this is a recycled code. Six refers to polystyrene. Okay, so polystyrene is a plastic-based material. It's mainly from styrene, produced from the polymerization of styrene, and the styrene is produced from benzene, which is the building block for the petrochemical industry. This is an example. Another example is the plastic bottles that you drink on. So you use every day. You go to the supermarket, buy a plastic bottle to drink mineral water. This plastic bottle is polyethylene terephthalate, which is a petrochemical. So this petrochemical is based on to produce this polyethylene terephthalate. We have two components in the building block here, which is the ethylene. Okay. We use ethylene to ethylene glycol, convert ethylene to ethylene glycol, and the xylene to paraxylene. We get paraxylene. We convert to terephthalate xylene is converted to terephthalic acid, and ethylene glycol react with terephthalic acid, produce polyethylene terephthalate, and ethylene terephthalate is polymerized to polyethylene terephthalate, which is a petrochemical. So in general, you use ethylene. You started the starting point for the production of your petrochemical was ethylene. Okay, Okay, you used xylene, which is one of the aromatics, but in general, this is a building block. So ethylene is you can get ethylene from natural gas. To get also one of the example for this, the cover of your plastic bottle is polypropylene. So the plastic bottle is polyethylene terephthalate. The cover of your plastic bottle is from propylene. Okay, it's called polypropylene. So the polypropylene is based on the polymerization of propylene. Propylene at the end is extracted from, or you can get propylene from the reaction or dehydrogenation of propane, which is one of the components of natural gas. Okay, so mainly the petrochemical industry is based on natural gas. There is other end products. So this is what an example of what I talked about, like the plastic bottles, the waterproof material. But there is other compound based on the petrochemical industry, like the adhesive, the glue that you go to the supermarket and buy it, or to the shop and buy it. Plastics, soaps, detergents that you use to wash your dishes and your clothes, all based on petrochemicals, solvents, uh, fertilizers, okay, and the nitrogen, ammonia, and all these are based on the petrochemical industry. Explosive, so TNT, all petrochemical industry, synthetic fibers, also petrochemical industry. Um, so many flooring, and also you will find the petrochemical industry in every place, or the petrochemical product in every place, in your home, in your car, and all of this petrochemical based material are the starting point of all this petrochemical industry, or this building block, which are extracted from natural gas. So we will divide, in general, the petrochemical based material on three paraffins. Okay, three classes paraffins. We will talk about C1 to C4 paraffins. What is the shape of these paraffins? What How they are produced, but like in a very short note. Okay, and then what is the product based on this? Oh, again, in a very short note, and not the production step. I don't want to for this lecture to be very heavy, or very concentrated. So we will talk about the paraffinic hydrocarbons for the petrochemical industry, the olefinic hydrocarbon for the petrochemical industry, the diolefins, and the aromatics. Okay, all these are based on one way by or another is a building block for the petrochemical industry. So in general, paraffins are straight chains, no double bond in the chain. They are less reactive than any other than the olefins. Okay, and they are mainly in the crude oil. So mainly present in crude oil and natural gas. So paraffins are mainly concentrated in the crude oil and natural gas. Natural gas contain paraffins. Crude oil contain paraffin naphtha aromatics. Okay. So the smallest member, or the first member on in the natural gas, is the methane. Okay, so methane. I don't know if this will appear here. Mm. So if you can see here, so this is the methane. So this is the molecule. The black one here is a carbon, and you have four hydrogen attached to this methane. Okay, I hope that you can see it. Okay, so for this methane is not very reactive. It is a colorless gas. You cannot. There is no smell. In general, the natural gas, or the leak, in if you find the leak, you will in the natural gas pipeline, you will smell, and this you will have a smell. This smell is the mercaptan, not the natural gas. Natural gas has no smell. It's odorless. Okay. So, for the methane, it's one of the important petrochemical in building block, and you can see it is on in the green circles here, the red one here. It is a paraffin. Okay. So, what can we get from the natural gas? Actually, methane here is the main component of the natural gas. It's like from 60% to 90% composition in the natural gas. It can be used actually as a fuel. So for the petrochemical industry, you need to have to increase the temperature of your furnace, maybe to 800 degrees Celsius, 900 degrees Celsius, or maybe higher. So to increase this to reach to such high temperature, you have to use a fuel. Methane can be used as a fuel. So this is one of the uses of methane. So the other use here is the oxidation of methane. Okay, so partial oxidation of methane. So if this methane react with with oxygen with O2, okay, what happen with we get is not complete combustion. So it is partial combustion. We get one of the valuable component actually, which is the carbon CO, okay, carbon and oxygen and hydrogen. Okay. The mixture of carbon and CO and hydrogen is called syngas. So syngas is very important for the production of methanol, for example. So methane can be converted to methanol through syngas. Also, one of the important uses for methane is to produce hydrogen. Okay, so because the methane is CH4, so one carbon to four hydrogen. Okay, so you can produce a lot of hydrogen from using methane. Okay, through partial combustion of methane. So this hydrogen is valuable in for the ammonia production, for example. Okay, so you use it to produce ammonia. You get nitrogen from the air, hydrogen from methane. Okay, and then you react. They react together and form ammonia. The ammonia are converted later to urea. Urea can be used to make urea formaldehyde resin, phenol from urea melamine, for example. So which is one of the important petrochemical resins. Okay. So syngas actually is one of the important. Actually, syngas are used from is a way to convert I'm sorry, coal to liquid. Okay, so coal or biomass are converted to liquid hydrocarbons through Fischer Tropsch from the combination of syngas, which is CO and hydrogen. Okay. So as I told you, methane is a way to get your to fuel your industry as a fuel for in general for refinery, for petrochemical, for your house, for cooking, for whatever. So it is a source for as a fuel, and also it is a source of carbon black. The next one is the methane. Okay, actually it is one of the component of the natural gas. So it has two carbon, okay, and six hydrogen. Okay. So the use of ethane as an ethane is not as a its current state here is not very useful. Okay, it has to be converted to ethylene to have a double bond. So we take one hydrogen, we take one another hydrogen, and we get ethylene, which is a double bond. We get a double bond. So this double bond is what which is converted from paraffin to olefin. So this is what we want, the double bond. This double bond, this ethylene, if it converted to ethylene, it can be polymerized to polyethylene. Okay. Also, ethylene can be used as a fuel also. Okay, because it's one of the component of natural gas. The natural gas contains some ethane. I'm sorry. Okay, and it can be used to produce syngas, which is a carbon monoxide and the hydrogen mixture. We talked about syngas, CO, and the one I showed you, CO and the hydrogen. Okay. So ethane by itself is not a building block of the petrochemical industry. Methane is a building block for the petrochemical industry. As I told you, is the route or the way using methane we can produce syngas. From syngas we can produce many other important petrochemical industry. Ethane by itself is not a petrochemical building block for the petrochemical industry. It has to be converted to ethylene. Okay, so ethane has a potential to be converted to ethylene. Propan. The propan again, they are paraffins. All what we are talking about here is paraffin. Paraffin, no double bond. It is a paraffin already existed in the natural gas. So methane is mainly natural gas is mainly methane, and ethane also is produced from natural gas, and the propane is produced also from natural gas. So there is a three carbon, okay? So three carbon attached to hydrogen. I don't know if it is clear or not, but hopefully it is clear. So actually, propane together with the butane is also used as a fuel, can be used as a fuel, okay, which is called LPG. LPG is one of the that you can find in gas bombs or well, no, it is called LPG. The way I know in Arabic it is أنبوبة البوتاجاز بس مش I don't know it in English. Okay. But anyway, so LPG is a source of fuel instead of natural gas for remote areas that don't have access to natural gas supplies in their home. So this is one of the way. Also, it can be used as as a car fuel. Okay. The cars that use gases can use LPG also. Anyway, so for the petrochemical industry, LPG as a mixture of propane and butane can be used to be converted to olefins. Okay, so LPG mixture of propane and butane can be cracked to olefins. So now, as a propane, as a propane, or which is a paraffin base, it is not a very of high use, or there is no many chemicals based on the propane, but the propylene is one of the important petrochemical or one of the building block for the petrochemical industry. So the difference between the propane and the propylene is the double bond. Okay, so there is double bond. Once we take two hydrogen from this propane, okay, using high temperature, it's called steam cracking. Okay, so using the steam cracking, we convert this propane to propylene, which is one of the important building block. Propylene can be used as a polymerized to polypropylene. What if you remember? I talked about the cover of the plastic bottle or the mineral water is mainly polypropylene. Actually, also polypropylene is one of the important um, uh, uh, um, plastic containers that can be used to enter the microwave. It is safe to be microwaved. So any container containing polypropylene is safe to use in the microwave. Okay, so the last one we will talk about on in natural gas, which is mainly one of the component, also one of the component of the natural gas. So methane, one of the component of natural gas, ethane, one of the component of natural gas, propane, another component of the natural gas, and the butane, which is the also another component or the fourth component of natural gas, and the fourth important one. The other component or the heavier one is not very concentrated in natural gas. So for the butane, so butane itself is one of the building block for the petrochemical industry, and it can be used to be converted to butylene, which is a double bond, butadiene, diolefins to double bond. So okay, so butane is one of the important petrochemical building block here. So butane as a paraffin can be used in the petrochemical industry as a building block. All can be converted to butylene, which is a double bond. Here we can see here. So it is a double bond, three straight, and here there is a double bond. Okay. And butadiene will talk. I will not show you butadiene now, but later I will show you what is a butadiene. So butane actually can be, I told you that it can be converted to butene or butadiene. It also can be converted to isobutene. Isobutene is one of the important materials to produce methyl tetrabutyl ether. Methyl tetrabutyl ether is a mixing material can be mixed with gasoline to increase the octane number. But actually, it is prohibited in the USA because of the carcinogenous effect for this source material. But in other parts in the world, it is accepted as a blend with gasoline to increase the octane number. Also, normal butane is one of the can be used to produce acetic acid and malic anhydride. So acetic acid is here. The composition of the acetic acid is here. Malic anhydride is here. Also, these are important intermediate material for the petrochemical industry. Now to the olefins. So we talk for the natural gas, the main component in the natural gas is paraffin. Methane is paraffin, propane is paraffin, ethane is paraffin, butane is paraffin. All are paraffin, but can be converted to olefins. For example, ethane can be converted to ethylene, propane can be converted to propylene, and butane can be converted to butylene. Olefins in the petrochemical industry is important. So it is very, very valuable building block for the petrochemical industry. So the petrochemical industry are mainly based on olefin. Okay. So the natural gas by itself has to be converted to olefin because natural gas contain paraffin, mainly paraffin, no olefin, and it has to be converted this paraffin to olefin to get more valuable material. Okay. So the starting material in the olefin is the ethylene. So ethylene is two carbon, okay, with a double bond between them, and there is a hydrogen also. Ethylene by itself is reactive. It can react with water, as you can see here, to get ethanol. So ethylene with water, we get ethanol, which is ethyl alcohol, the alcohol that you get to sanitize your hand and whatever for coronavirus and other components. So ethylene is a valuable component. It is reactive. It can react with water to get ethanol or ethyl alcohol, or can react with chlor, okay, Cl2, as you can see in this reaction. So ethylene react with chlor to get a dichloroether or ethylene dichloride. Ethylene dichloride is using a very high temperature is converted to vinyl chloride, which is later converted to polyvinyl chloride using polymerization. Polyvinyl chloride, I talked about it in the start of the lecture. Polyvinyl chloride is one of the important plastics. It is a waterproof plastic, and many coats and any waterproof material are mainly produced from polyvinyl chloride. Also, ethylene can react with the benzene here to produce ethyl benzene. Ethyl benzene can be converted to styrene. So ethyl benzene, we take hydrogen from here, we get double bond, which is a styrene. Styrene can be converted to polystyrene, and it is polystyrene. It is the cover of your coffee, the paper coffee cup. The cover of the paper your paper coffee cup is styrene. Styrene by itself can be polymerized to poly. I'm sorry. Ethylene by itself can be polymerized to polyethylene. Okay, polyethylene. Polyethylene is used in many materials that are you like the you if you the containers, the plastic containers, the toys for the children, the cover for the um, uh, greenhouse covers if you want to in the agriculture and so on. So there is many uses. Ethylene also can be used to produce ethylene oxide. So as you can see, so a single molecule, you get this single molecule, this ethylene from the ethane. The ethane is one of the components of the natural gas. So ethane is converted to ethylene. Ethylene is one of the important building block for the petrochemical industry. It can be converted to ethylene oxide, and ethylene oxide is converted later to ethylene glycol. Ethylene glycol is one of the component of the plastic bottle, polyethylene terephthalate. Okay, so from ethylene, started with ethylene, you get your plastic bottle. Okay, so okay, so for here, if you have your ethylene here, okay, ethane, ethane here is converted to ethylene through cracking, which is called steam cracking. Okay, steam cracking. Propylene. Propylene, again, it is the same way as you treat ethylene is a propylene, but actually the use for or the need for polypropylene is not as high as the polyethylene. So propylene is produced from the dehydrogenation of propane. So which is called steam cracking. So we have the propane here. Okay, we take two hydrogen here and we get a double bond. So the difference between the propane and the propylene is a double bond. Okay, is a double bond here. So this propylene by itself it can be polymerized to polypropylene. Polypropylene is the cover of your plastic bottle. Polypropylene is the cover. Remember, it is the cover of your plastic bottle. So it is converted from propane to polypropylene using steam cracking. So we use a very high temperature furnace, like the one it's one in the background here. The one here is the furnace. Okay, so this furnace is we introduce the propane or we feed the propane at very high speed, maybe seconds or not seconds, millisecond. Residence time in this furnace is millisecond. The propane is cracked. Using steam, we get also steam is fed with the propane, and it is converted to propylene. In this process, sometimes we use catalyst. So for the propane, ethylene, we don't use catalyst. For the propane, sometimes we use catalyst. It is a catalytic based process. Okay, so why propylene? Is it only to get polypropylene? No, propylene can also be used to produce isopropyl alcohol. You know the rubbing alcohol, the rubbing alcohol. Okay, so one of the alcohol used in also for sanitizing and is better to use than ethanol. So isopropyl alcohol, okay, is produced from propylene. Allyl alcohol, acrylonitrile, glycerol, and so other components are based on propylene. Butylene. Again, butylene also is produced from the cracking or steam cracking of butane. 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 Okay. So the butane here is for all straight chain, single chain, single chain. Paraffins. Okay, so the butane is paraffin. Dehydration of this butane will give us butene, a double bond here. Okay, this double bond in any of the olefin make it able to like this part double bond can be cracked, okay, and link it to the other propylene or whatever propylene, butylene, whatever you want to polymerize with. So butylene, okay, cracking you crack this bond and butylene will react with other butylene, reacts with other butylene. So this double bond is a way for this butylene to react and form polybutene. Okay. This is why also building block for the we finished the olefins. We talked about paraffins. We talked about olefins. Okay, so let's see which of what is the building block that we talked about. We talked about methane, which is a paraffin. We talked about ethylene, which is produced from the dehydrogenation of ethane. Okay, which is one of the components of natural gas. We get ethylene. Again, propylene, one of the component of propane is based on natural gas. So propane, dehydrogenation of propane, we get propylene. Butane, one of the components of natural gas, we talked about it. Butylene also can be produced from the dehydrogenation of butane, okay, which is based on steam cracking. Butadiene, we didn't talk about. We are going to talk about what is diolefin. What is meant by diolefin? Actually, diolefin, I would say it is the winning card for the petrochemical industry. Why? Okay. Actually, the diolefin contain two double bonds. In general, when we talk about ethylene, there is one double bond. Propylene, it is one single bond. I don't know if this is clear. One single bond and one double bond. Okay. Oh, one double bond. Actually, for the butadiene, it is different. We have two double bond. Butadiene, we have two double bond here and here. Okay, connected together with a single bond here. This single bond. Hopefully that you can see what I'm illustrating. I don't know if the video is clear, but hopefully I am. So we have here four carbon, okay, molecules or carbon atoms. I'm sorry, and then we have single bond, and then one double bond here, and the other double bond here. This is called conjugated diene. Conjugated diene. What's meant by conjugated diene is a double bond, and the double bond are separated with a single bond. The double bond cannot be together, cannot be linked because you can have a double bond here and double bond here. You can have a double bond here and the double bond next to this carbon, next to this double bond. In this case, it is non-conjugated. I'm sorry. Okay. I'm sorry, it's not, I'm sorry, this is conjugated because it's separated with only one single bond. For the non-conjugated, it is separated with more than one single bond. Okay, I'm sorry. For the so it is butadiene. So this, in case, this is butadiene. Two important diolefins in the for the petrochemical industry. The first one is the butadiene. If you look at the butadiene and the many components that you can get from the butadiene, you will see how it is important. For example, butadiene by itself can be polymerized to polybutadiene. Okay, butadiene can react with styrene and give butadiene styrene rubber. Okay, so this is one of the SPR. If you remember SPR rubber, if you come across this type of rubber. Okay. Also, the nylon 6,6, one of the important fibers, okay, and one of the important plastic components. So we have adipic acid, can be produced from the butadiene. Hexamethylene diamine can be produced from fumed butadiene. Hexamethylene diamine and the adipic acid and the hexamethylene diamine can react together and give nylon 6,6, which is based on the butadiene. Butadiene are produced from natural cracking of bioproducts from cracking of propane or cracking of butane, or can be produced as a byproduct from the cracking of naphtha, not by natural gas from the crude oil. Also, butadiene can be react with the chlor and polymerize to get neoprene. Neoprene is type of rubber. This is the shape of neoprene. Okay, so this is why butadiene is very important rubber, very important based material. It can be used for cross-linking if you the resins or the glues. Okay, so all are butadiene is one of the components used for cross-linking. Okay, so to make this plastic type is not cannot be cannot melt. So to change the characteristic, not working of the polymer. Okay, so if you have a two chain of polymer and do cross-linking or networking between this two straight chain polymer, you get a network or cross-link, which change the property of this plastic. Instead of, for example, the plastic bottle is thermoplastic. If you heat it, it will melt. Okay, using some cross-linkers such as butadiene can change the properties of some of the polymer to, instead of being able to melt, it will not melt. Okay. So one of the other important compound is the isoprene. Isoprene also is a conjugate diene. So we have double bond, single bond, double bond. So it is separated by only one single bond. Okay. It can be produce butyl rubber, or again, it is rubber. So rubber is rubber does not is a thermoset material, plastic, which does not melt. You cannot melt rubber. You will burn it. You will not melt it. The last thing what we have here is the aromatic hydrocarbon. Aromatic hydrocarbon cannot normally be extracted from natural gas. All the past material can be used and extracted and converted using natural gas but aromatic cannot using normal conditions or normal ways. You can actually recently there is a Fischer Tropsch process that you can get a gas to convert gas to liquid, and then from the liquid you could extract benzene, toluene, and xylene. So this is one of the way. But aromatic hydrocarbon compound is very important, especially benzene. For example, the styrene. Styrene cannot be produced. Also, you have benzene or ethyl benzene. The plastic bottle is based on xylene. Xylene is an aromatic compound. So actually, benzene is extracted from naphtha, and the naphtha was using solvent extraction. I don't know your background about the refinery industry, but in general, using the distillation, using crude oil is a mixture of many components. Using the different in the boiling point, we separate the material to many fractions. For example, we have gas oil or naphtha, light naphtha, heavy naphtha, gas oil, and a residue from the top. So for simplification. So this naphtha is very rich in benzene, toluene, and xylene. Sometimes they are the heavy naphtha can be catalytic using catalytic reforming. Okay, to maximize the amount of aromatic in this naphtha, and we extract this benzene, toluene, xylene. Light naphtha can be used for cracking of this naphtha to produce olefins and benzene, toluene, xylene. Okay, so naphtha actually is one of the important component from the crude oil, and is very important in the petrochemical industry in general. So benzene is one of the aromatic component, cannot be using normal or commonly known method, is not extracted from natural gas, but it can be extracted from natural gas if we use Fischer Tropsch process. Also toluene, one of the important. For benzene, we convert benzene. Benzene react with ethylene and produce um, uh, uh, ethyl benzene. Ethyl benzene is dehydrogenated. We get styrene. Styrene is polymerized to polystyrene. Polystyrene, as I told you, I remind you, this is the cover of your coffee cup. Okay. Also, if you see, this is also polystyrene here. This is polystyrene. The photo that I show you. Um, uh, uh, so to preserve any equipment, heavy equipment, or fragile equipment, also use polystyrene. Benzene can be used to produce nylon 6. Okay, nylon 6 is based on butadiene, which can be produced from natural gas. However, nylon 6 is based on benzene. So this is the process that I talk about. Benzene is react with ethylene to give us ethyl benzene. Ethyl benzene is dehydrogenated to styrene. Styrene is generally polymerized to polystyrene, or react with butadiene to get styrene butadiene rubber. The last two important compound in the aromatic compound, again, this aromatic compound are not produced from natural gas using normal process. It can be produced from natural gas or from biomass or from coal using Fischer-Tropsch process, which is called gas to liquid (GTL). Okay? If you see the GTL process, it is the gas conversion of gas to liquid fuel. So this liquid fuel contain many compounds, ester and aromatics and so on. So one of these will be benzene, toluene, xylene. Actually, the commonly used toluene is not used commonly in the petrochemical industry, and the excess of toluene are converted to benzene, are dehydrogenated. So the toluene here is dehydrogenated to benzene, and benzene can be used in many other products, to produce many other products, as I showed you. Paraxylene is the most important xylene isomer here. Okay, it is used to produce terifacelic acid, which is the component one of The base for polyethylene terephthalate is the plastic bottle. Your plastic bottle are produced from paraxylene here, okay, to produce is terephthalic acid, okay, and this terephthalic acid react with ethylene glycol. This ethylene glycol are extracted from ethylene, or not extracted, are based on ethylene. Ethylene is based on ethane. So ethane is dehydrogenated, converted to ethylene, and the ethylene is then converted to ethylene glycol. Ethylene glycol react with terephthalic acid, produced ethylene terephthalate. Then polymerization, we get our plastic bottle. It's not as simple as this reaction, but in general. Okay, so the last chemical that we will talk about is the orthoxylene. So actually, the metaxylene is not very you. I forget to show you the benzene. So this is the benzene ring. Okay, so this is the benzene ring. So we have six molecules here. Okay, and there is double bond, double bond, single bond alternating. Okay, and one hydrogen. Okay, so this is the benzene ring. Xylene is we substitute one of this hydrogen with CH3, and then another hydrogen with CH3. The place of this CH3 is will define also meta and para. So the meta is not very useful in the petrochemical industry and is generally converted to paraxylene, which is used in the plastic bottle. Also, xylene also can be used as a plasticizer, but it is not very commonly or as of high demand as the paraxylene. Of course, the plastic bottle. As a revision for what we have talked about, we talked about the petrochemical industry are based on raw material, which is crude oil, natural gas, and coal. This crude oil, natural gas, or coal can be converted to, or can extract from them the building block for the petrochemical industry: methane, ethane, propane, butane, pentane. Okay, not pentane. So methane, ethane, propane, and butane from natural gas. We have to convert this paraffins to olefins, so methane. Then we convert ethane to ethylene, the building block, propane to propylene, butane by itself, and the butane to butylene, and to butane to butadiene. So this is based on natural gas. For a very limited industry like Sasol in the South Africa, Fischer-Tropsch process or gas to liquid. Also, this is found in Malaysia. I think we can convert natural gas to benzene, toluene, and xylene. Another building block for the petrochemical industry. Hope that you everything is clear and I showed you or reached to my point.